Okay, this is our last lesson on equations involving indices. So our last lesson on indices altogether, really. Okay, so I suppose yesterday we practiced basic ones, and the most important thing that we had to remember was that the bases must be the same. Okay, otherwise we can't let the powers equal unless they're the same. Okay, so yesterday they were nice and straightforward in that the bases were already the same. Today we're doing ones where the bases aren't the same. Okay, so these are more difficult now than yesterday's ones. So make sure that you have your homework corrected from what I put up online on Edmodo. Make sure that you have it corrected, that you've checked anything you went wrong, and that you understand where you went wrong, and that you understand how to do it now. Okay, right, so I suppose the first one here, so we have 4 to the power of x equals 16. Okay, so remember the bases must be the same, so we're in trouble here. We can see that this base is 4, this base is 16. Okay, so before we can even think about the powers, we must make sure that the bases are the same first. Okay, so I suppose we need to look at 16, and can that be changed to base 4? Yes, it can. It can become 4 to be squared. Okay, so this one was base 4, so I checked to see if this one could also be changed to base 4, and it could. It could be changed to 4 squared. Okay, so now the bases are the same, so I can let the powers equal. I can say x equals 2. Okay, so that's the extra step in these ones now, that we must make the bases the same. Okay, down to this one. So next, so again we can see this base is 16, this base is 64, so again we're in trouble here. Okay, so I suppose first if we check 16, can 16 be, or sorry, can we change 64 to base 16? No, we can't. Okay, because if we go to the calculator, if I put into the calculator 16 squared, that's 256. Okay, so we can't change 64 to base 16. So actually we need to change both bases this time. Okay, so I need to think of a base number that will work for both. And actually both of them can be changed to base 4. Okay, you could also change them to base 2 as well. Okay, I'm going to go with base 4 here. Okay, so base 2 would be perfect as well. So we're going to change both of them to base 4. Okay, so 4 to the power of, I'm going to go with 3. And that works. Okay, so again, it's a bit of trial and error in the calculator here. Okay. And then over on this side, we have 4 to be squared will give us 16. And outside that again is the x. Okay, so 16 becomes 4 squared, and I have x outside that again. 64 becomes 4 cubed. Okay, so our rule here, so for power raised to power is multiply. So 4 to the power of 2x equals 4 cubed. Okay, so our rule there, power raised to power, means we multiply them. Now our bases are matching, so we can now let the powers equal. So we're saying 2x equals 3, divide by 2, so x equals 3 over 2. Okay, so remember we must keep going until we've solved for x. Okay, number 3. Okay, so we're looking at the bases. This base is 3, this base is 27. Can I change 27 to base 3? So if I check my calculator there, if I go with 3, I'm going to guess 3 cubed is 27. Okay, so 3 to the power of x equals 1 over 3 cubed. Okay, so I've changed 27 to base 3. Okay, however, we don't want this underneath the line. Okay, so we flip the fraction. We know that means that the sign changes of the power. So that's now 3 to the power of minus 3. Over 1 if you like, but we know that doesn't make any difference, so I'm going to leave it out. Okay, over 1 means nothing. So we can get into the habit now of leaving out that over 1. If you want to write it in grand, just put in the next line then as just 3 to the power of minus 3. Now our bases are matching, so we can let x equal to minus 3. Okay. You can obviously pause the video and go back over it again if you find this is moving very fast. You know, you can pause it, go back again, make sure you understand each one before you go on to the next one. Okay, next one, so we have base 25, base 125. Okay, so can I change this to base 25? So if I check 25 squared, that's going to be way too big. Okay, so I can't change 125 to base 25. Okay, so what can I change both bases to? I can change the both bases to 5. Okay, so the 25 becomes 5 squared, and outside of that is still x. On the other side, 125 will change to 5 cubed. Okay, and again, trial and error in the calculator will get you that. Okay, you can nearly take a guess at them anyway. If it ends in 5, if the number ends in 5, then the chances are the base will be 5. Okay, so just take a good calculated guess at it and then try it in the calculator. Okay, so then we can tidy it up. So power raised to power, we multiply it. And on this side, we need to bring the 5 to be cubed up. So we flip the fraction, and it becomes 5 to the power of minus 3. And I'm going to leave out the over 1 because it doesn't make any difference. So now they're both 5 to the power of. So let the powers equal. So 2x equals minus 3. X equals minus 3 over 2. Okay, last one. So again, the base on this side is 9, this base is 27. So can I make 9 the base of 27? If I go with 9 squared, that's 81. So no good. Okay, so I'm going to try 3. Can I change both of them to 3? So 3 squared would be 9, 3 cubed would be 27. So I'm going to change the base to 3. So we will then go with 3 to be squared to 2x minus 3 here, and 3 to the power of 3. Okay, change both bases to 3. Okay, power raised to power we multiply, so 2 times 2x is 4x, 2 times minus 3 is minus 6. Equals, flip the fraction, 3 to the power of minus 3. Okay, now the bases are matching, so I can let 4x minus 6 equal minus 3. So 4x equals 3. X equals 3/4. Okay. So you might just write beside each one what we changed it to, what base we changed it to. So in the first one, we changed the base to 4. In the first one, the second one was also changed to base 4. The third one, we changed it all to base 3, base 5, base 3. Okay, now look, I know these are tricky, but this is as difficult as it gets now. This is the last part of indices. Okay.